Okay, here's your conceptual development ones. All right. First of all, the g of x, that is this graph. That's the one they give you. They don't give you f of x. You got to draw that. So f of x actually, it's going to look something like this. X to the sixth. So it's going to look like this. All right, it's going to be a little bit thinner than this is. It's going to climb at a steeper rate after those. All right, so now you're comparing these two graphs. That's what they're asking you to do. You're answering questions about both of these. So again, this is f of x. This is g of x. All right, so it says compute the average rate of change. Again, average rate of change. They want the slope. And they want the slope for the two functions on the interval -1 to 1. All right, so when you're comparing them on this interval, that means these are your x's. This is your first x. This is your second x. All right, so for the g function, we're going to find g of -1. Well, g of -1, if we go to -1, it's at, the graph is at 1. So it's 1. All right, and then we do the other point, the other one. So we're find g of 1. All right, and 1 again, if we go to 1, it is going to be 1. All right, so now if we compute the slope for this point is -1, 1, and 1, 1. So all we got to do is put that in our slope formula. Again, it's x, y2 minus y1, so it's 1 minus 1 over 1 minus a -1, which gives us 0 over 2, which is 0. All right, and then we do the same thing for the f function. Now the f function, you may want to use the x to the sixth and do that. So if I put a -1 in there, that gives me, when I put in the -1, again, to this, -1 to 6 is just 1. And then when I put in the +1, 1 to 6 is just 1. So I get 1, 1. So you'll notice these 2 points are the same as these two. So again, the slope is going to be 0. So it says compare the average rate of change. So I would just say that slopes are the same. All right, now you're doing the same thing, but now you got a different interval. Now we got -2 to +1. Well, +1 we already have for both of them. All right, so for the g function, the g of x function, we already know that we have 1, 1. Now we've got to find -2. Well, -2 goes up to +4. So it's going to be -2 and +4. So again, we'll do the slope again. So 4 minus 1 is 3. -2 minus 1 is -3. So I could get -1. So the slope of that would be -1. All right. Now, do the same thing, but this time we're going to use the f function. So the f function looks like this. Again, it has 1, 1. We already know that. Now we got to use the -2. So put the -2 in here. Well, -2 to the 6th power is 64. So we got -2 and 64. So again, doing the slope, 64 minus 1 is 63. -2 minus 1 is -3. So we get a -21. So on this one, we're going to say the slope of f of x is much greater. All right, and then the last thing in that problem you have to do is compare the end behavior. Well, the end behavior, g of x, as x goes to positive infinity, it's going to positive infinity. F of x going to positive infinity, and they're both. So the end behavior is the same for both functions. All right. Now this problem is a little different on the it's going to be different on the on my key for this for the review, because I used x to the 6th or x to the 5th power. So it's going to be a little different. So that one you just got to look at. All right. Number 2, this one should be fairly basic. All right. It's asking you to describe the key features of the graph. All right. where does the graph intersect the x-axis? Well, that one should be a pretty easy one. All you got to do is take x minus 2, set it equal to 0. So that would be at 2, 0. Take x minus 1, set that equal to 0. Again, where it intersects the x-axis is the same as the roots of the zeros. So take x minus 1, set that equal to 0, and we get 1, 0. And then x plus 3, set that equal to 0, and we get negative 3, 0. So those are your x-intercepts. All right, now it asks for the y-intercept. All right, to get the y-intercept, what you have to do is you have to put zeros in here for all these x's. All right, and then you have to figure out what it's equal to. So we have negative 0.5 times negative 2, because 0 minus 2 is negative 2. 0 minus 1 is negative 1 squared. And then 0 plus 3 is 3 squared. All right. That gives us a negative 0.5, negative 2, negative 1 squared is 1, and 3 squared is 9. All right. So a 0.5, and at times, this is 1/2 times the negative 2, it's just going to give us a negative 1. And you can see we have negative 1 times positive 1 times 9, that gives us a negative 9. So 0, negative 9 is where it crosses over the y-axis. All right, now for these next two questions, what you should probably do is just get a quick graph of what this graph's going to look like. So this graph, all right, we already have our zeros. Our zeros are at negative 3, positive 1, and 2. All right, we know the leading coefficient is negative, and the degree is, let's see, we've got x squared, x to the 5th, so it's a 5th degree, so it's a odd, and leading coefficient is negative, so it's going to go down this way, and it's going to go up this way, and we got at here we have a square and we have a square, so we got 2 where it's going to be turning. All right, so it's going to go through here, it's going to come back down to this one, it's going to turn, and then it's going to turn again to come here, and then it's going to turn again. So it's going to look something like that. All right, so knowing that, now we can answer all these questions. All right, so is the value of the function, f is the function, positive or negative for the interval from 2 to 3? So here's 2, here's 3. So this is really just asking you, is it above the x-axis or below the x-axis? And in this case, from 2 to 3, it's below the x-axis, so that means it's negative. All right, is the graph increasing or decreasing when x is greater than 5? So it's out here. We already know that this is going to negative infinity, so it's decreasing. All right? And again, that one's different than the one that's on the review that you have, that I have. I might even not send that out. All right, so then our last one. All right, last one here, the area of a rectangle. So this is the area formula for a rectangle. So this is length times width. All right, so that means that the length is x and the width is 5 minus x. So what values make sense? What values of x make sense for this problem? Well, we know the length can't be negative. So that tells us that x has to be greater than 0. All right? And this one tells us, again, our width can't be negative. So if I put any number that's bigger than 5 in here, it's going to start giving me negative numbers. So I know that x for this one has to be less than 5. So all you got to do is put these two together. So x, so we got 0 is less than x is less than 5. So that just tells us that x has to be between 0 and 5. Which makes this next part easy, because we only have to graph this for the values that you identified in part A. So we only have to graph it from 0 to 5. All right? So if you want, you can make a quick table. X, Y table, 0, 1, 2, 3, 4, 5. Plug the 0 in. So you have 0, 5 minus 0, that gives us a 0. So 5 is going to give us a 0 because, again, this is going to give us a parabola. So we have a choice of 1 or 4, so I'll put the 1 in. 1, 5 minus, that gives me a 4. Alright, and then the 2 and the 3, put the 2 in. 5 minus 2 is 3 times 2 is 6. So we didn't find our vertex, but we do have a graph of it. So it looks like this, 0, and then it goes to 4, 1, 4, 2, 6, and then it repeats. Oops. So it's going to look like that, something like that. All right, so that was graphing it. And then the last part is what dimensions will result in the maximum. Maximum. All right, so now we need the vertex. You can see the vertex is between 2 and 3. It's actually halfway between those 2 points. So it's got to be at 2.5. All right, so the vertex is when x is equal to 2.5. All right, so that gives us the dimensions. We already said the length is x, and x is 2.5. So the length is 2.5, and the width is 5 minus x. So it's going to be 5 minus 2.5, which would be 2.5. So the length and the width are both 2.5. All right, and that will give us the max.